So here you can see a bit of structure for today. So first I want to say a few words about how we approach integrated catchment modeling. Then I've divided the topic into 3 themes. So we talk about interactive data management, Snappy network analytics, and fast flood simulations before we wrap up in half an hour or so. Okay, so let's move on. So integrated catchment modeling, why is that talked about so much around the world? So complex urban environments require a bit of thinking. You get rain coming, turning the runoff, entering pipe systems, then you got flooding over there, some stormwater management systems over there. And how do all these come together? How can you analyze them in a holistic manner in order to make good investment decisions as a utility, for example, or as a designer, how to take into account all these moving parts and then find a suitable solution for your client. So let's have a look what this includes. So typically we talk about catchment modeling as such, and that's often what integrated catchment modeling includes. So you have the hydrological catchment simulations. So in our case, we got some swim modeling there to cover rainfall runoff simulations, groundwater, snow melt, and many other phenomena. Then you combine that with hydraulic simulations for stormwater or combined sewer systems, including pipe networks, open channels, pumps, and all kinds of network infrastructure. And then, importantly, you combine all these parts with the overland flood simulations. And then you start having a good holistic package where you can simulate the hydraulics and hydrology in one package. But that's not all. I like to emphasize that we think you have to include also stormwater planning aspects, such as stormwater management measures, basins, flow controls, and so on. Also catchment-wide green infrastructure methods to assess bioretention, rain gardens, green roofs, and their impact to the urban environment and hydrology. And not to forget water quality that you can also analyze and you should take into account when you think about the holistic catchment modeling. And lastly, we think data management is really important in all of the above. So we incorporate also elevation models into our modeling system. We got the network data, all kinds of GIS data sources, and importantly, the analytics to really understand what's going on and then develop those plans and designs. So this is what we think integrated catchment modeling is. And this is what we're going to talk about today, at least the main points of it. So if this sounds a bit overwhelming, so there's too many moving parts and so many things to consider, I like to just say that at Fluidit we think we can do this at many levels. So you can keep it simple for some quick design, so you can just analyze a smaller area very quickly. And we want to keep that simple. Or you can always dig deeper into some comprehensive data analytics and really go behind the data and try to understand and visualize it the best way possible. So you can always approach at the light level or go much deeper with more time and energy. So today we got these 3 topics, as I mentioned. I'm gonna cover the number 1 and number 2 first with some highlights, and then we look at the model, and then we move on to the flood simulations with more details and some examples. So first, start with interactive data management. I wanted to highlight a few things before we look at this in the model. So with us, the model size is always unlimited to start with. So as big as you want, as extensive as you wish. And also all the model data and the results are stored in one file. So no more playing with folders and missing files and so on. It's all in one neat package. We got a heap of options for importing and exporting GIS data or other models made with other software packages. Then we can provide links to online data sources, including these digital elevation models, which are fully embedded in the modeling environment. We got scenarios that are again unlimited and they inherit properties from their parents. You can manage data in many ways, such as tables, queries, scripts, and so on. And then there are a whole lot of tools made for designers. When you build a model, you can create model, edit it very quickly with all kinds of little tools that make life easier. So that's the sort of first context I wanted to highlight. But before we go to the model, the second part I quickly cover to give you an overview. So with the network analytics, behind the scenes, we rely on the robust Swim engine, which we've of course enhanced for our purposes. But that basically comes with full features for stormwater and combined sewer systems. So there's all the components you can think of and the processes on catchments as well. In terms of analytics, you can query data interactively for model building, but of course for analysis and all kinds of presentation purposes. As with the customizable visualizations, you can see on the right as well that it's an example of what you can collate in our software, collating maps, figures, long sections, cross sections, and all kinds of data you can calculate and further process to show the results you want to see, or show the results you need. For stormwater design, I really want to emphasize the profile view. That's very handy when you look at network, and there's more opportunities with Python, of course, so you can really go deep into analytics if you wish. That's the sort of quick overview before we now jump into the software to look at some of the main things. So we only got little time, so have to focus on some major aspects. So now you can see our user interface broadly. So it's a map-based platform for GIS data and all kinds of other tools you can use for result visualizations and so on. So I've got here an example stormwater model with some background data. You can see that we got clearly elevation data behind it. We can create contours from the elevation data. And you can then analyze your project area very nicely with the background data you can choose from various online sources. For example, we got OpenStreetMap. You can bring in from Bing. You can use file layers to use, shape files, CAD files, and so on. And then importantly, some links to the data servers where you can just link to your organization's data server and use your own background layers very smoothly. Many options on that front. What else you can see here? Just the user interface, which is fully, customizable. So these things move around to improve your workflow. You could place these in different parts of the model, and just customize it for your best workflow. But today we don't go too deep in that. You see some examples, and I hope that gives you the first impression. All right. So with this example, I want to also highlight some import tools very quickly, some import options. So you can, of course, import your model files from vector sources or other types of data. You can import them, and then you start working in our environment. So we think that it's best that you only bring in the data into Fluidit, and then you really keep on working within Fluidit. You can do all the operations you need in our software, basically. So I got some example here about data review. I will quickly show you that often when you import your data, you have some missing information. So you could, for example, use these sort of visualizations that already crunch and find the anomalies in your data. For example, you get highlighted areas where the profile needs to be checked. There's some nodes with clearly missing elevations, or there are some missing connections and so on. So you can import the data and then use one of these powerful tools to identify the gaps in your data. That's a sort of starting point. Once you move on from that, we can then start looking something a bit more complete, and therefore I change scenario. So you can see over here this scenario three where you can freely create scenarios. You can further create child scenarios, and then there's no limits to the structure you create for your project. But today I've kept it quite simple with just 2 levels of scenarios. So we move on to one example I've done, and I also then want to change the visualizations for it. So here we got an example where we got a proposed development basically within an existing area, a typical stormwater case where we've gotten this part of the model is new. So we got new building proposed there, and then we got a couple of buildings proposed on this area. For this example, I'll actually use the DM modification, so you can modify the ground elevation models on the fly. So I will just show you some examples on that. So if we look at a profile view, such as use this pipe as a section, you can see that it always fetches the elevation data from the model wherever I move the section. So it's always dynamically moving. If I were to change elevations over here, for example, I could then visualize the changes immediately. If I made it, for example, 86, I could just simply see the changes happen on the long section automatically, and also I would see the changes happen on the visualized ground model immediately. So just wanted to highlight it's an interactive process. So once you have your model in the Fluidit Storm, then you can really start playing with different kinds of options. Very simply, you don't have to go back to QGIS or somewhere else to modify your elevations. You can modify them here and then create some scenarios very quickly to assess options. So in terms of hydraulic analysis, we could look at one example from the schematics. So the schematic is a feature where you can collate all kinds of, well, basically our result features in one place. You could call it like a PowerPoint presentations on steroid, because you can collate information, you can write text and so on, but it's not just an image, they're dynamic results. So for example, if I move on with the time step, you can see that all the figures are changing, the levels in the basin are changing interactively, as well as the map is updated based on the current time step, which at this point would be 9 minutes. So these are fully dynamic with the results, and also if I change the scenario, it would load the results from another scenario. So the point of this is to create dashboards for your workflow. So when you're working, you create some of these dashboards, which we call schematics, and then you have them readily available for your work. So you can then just simply do some changes to the network and see how it works on the analysis side. So in this case, we've analyzed a couple of basins. You can look at the hydrographs, the volumes, how they work, and also overlay with rainfall and so on. So there's unlimited opportunities here. One little snappy thing I want to show you briefly is that you can also calculate basin volume or the elevation area curve automatically. So you could, for example, come here and just calculate basin, and you would just, lasso over the high points like this. I will ask you just a resolution, let's say 1 meter resolution at 0.1 meters. It will create the area, the storage curve for your basins directly from the ground elevation model. Something very handy for design purposes. Okay, but at this point, let's move on. So let's talk about the flood modeling a little bit, because that's one important part of this integrated catchment modeling. So with Fluidit, we got few options, but all up, it's very simple to set up, and simulations are fast. I got some examples of the simulation times for you in a couple of slides. So we got the fully coupled simulation, which I'll explain with an example very soon. You can, of course, use the 2D only simulation, or you can use an ultra-fast one-way overflow simulation, which I'll also explain you soon. Important for flood simulations that all the DEMs, the ground elevation models, they are layered and seamlessly merged together. So you can bring in from various sources, from online sources, from file sources, and they will be beautifully merged together to formulate your ultimate ground elevation model for simulations. So you don't have to make that by hand in other software. And as I noted, you can also modify the DEMs on the fly. And another nice thing, you can fetch buildings from OpenStreetMap. So to create obstructions, because of buildings, you can just fetch them from OpenStreetMap. Or of course, if you got a GIS layer from City Council, you can import it and use it as such. And then another thing to highlight is that while you simulate the flood simulations, it also post-processes all the raster results automatically. So there's no post-processing required. Okay, let's look at an example here. So what is fully coupled 1D, 2D simulation? On the left, let's quickly explain. So we got the 1D domain underground, the pipe network, and then we got a 2D domain above ground. And we've put this together using Swim Engine for the 1D and then CA Flood for the surface flow simulations. And how it looks in the actual simulation. Let's look at this animation, which is 100% done in Fluidit Storm. So in this example, we now start having rainfall on grid. The rainfall accumulates, of course, and as you can see, if I pause here, we are having flow at crater inlets going into the system at these rates. So you can, of course, give them colors and different styles, but that's the rate the flow is going into the pipe network. All right, as it progresses and the rainfall ends, then you can start seeing that the network is sucking in the final puddles from the streets until it's eventually dry. So that's a fully coupled simulation. With these animations you can make in the Fluidit Storm, you can also create these tools for your meetings. When you meet your clients, it's quite nice to show these kind of visualizations to explain what's happening on site, what are the problems, and then how you're going to fix them. So that's fully coupled simulation, really powerful tool for urban analysis. Then let's look at some simulation speeds. So on the left, we got the example you just saw, the fully coupled simulation. Just for some stats, it was 9-hectare area at 1 meter resolution and 3 hours recording max results and time step results. So that thing simulated in 2 minutes and 30 seconds. So that's a rather fast simulation. So the rule of thumb, we all like rule of thumbs. You could say 10 to 20 seconds per hectare at 1 meter resolution, for example, roughly. Then the right-hand side example is the overflow analysis style manual simulation where you focus on the 1D network first. You simulate the 1D network, and then you use the overflows from junctions to as an input to your 2D domain. And that's much faster in terms of the simulation. So, this area that is 5 times larger than the fully coupled, you can simulate it in the same sort of time frame, 2 minutes, 20 seconds, for example, in my typical work laptop I'm using. The point here is that you should select the appropriate method for your analysis. It's often smart to start with something slightly coarser, like this manual simulation on the right, where you get to understand the overflow locations, the problem areas on your site, and so on. You can do that very quickly for large areas. And then you can start focusing on some, couple simulations in some key areas, for example. That would be my workflow in a typical case. Okay, do we have some other time savers? We could list many time savers here, but a couple I want to highlight for you, stormwater engineers and people in the stormwater field. So we got design storm tool. So you can create design storms. Just a few clicks, you select the recurrence period, the rainfall duration, and then you can also apply patterns to it. And this is, of course, something we can customize for different geographies, but that's a very handy tool for designers. And then another handy tool I want to highlight are the weather stations, where you can fetch and interpolate public weather data directly in our model. So you only get you get from the weather stations, and you can source like rainfall, temperature, any data they provide. You can fetch directly in our software. No more going to the agency website, downloading some Excel, formulating it again, importing to our model. Just do it within our model with the tools we have. So very, very practical. All right. So some takeaways from this session, very brief session. So we talk about interactive data management. So remember, there's absolutely no limits what you can do. You can import and export most formats. You can manipulate the data very well in a very structured manner. And once you get to the analytics, we got lots of tools for designers that make your design process much faster. We got the graphic interface with the ground elevation models you can interactively play with, and all kinds of other tools. Then the fast flood modeling, as I said just now. So we got a few nice options for different parts of your project. So you got the course method for initial assessment, and then you can have the detail methods for more detailed analysis. All right, but that's what I can cover in 20 minutes. So I hand back to James. Thank you.
Yes, sure. Thank